Welcome back, welcome back, welcome back to science. All right, exploring lymphatic tissues and lymphatic organs. We're going to have two major categories of lymphatic tissues. Some of it's going to be unencapsulated, and you're going to find these in different regions of the body, and some are going to be very encapsulated. And we're going to look at the two different types. We're going to have a brief overview of the unencapsulated, and then we're going to really look at the encapsulated as what it each does at each location. So unencapsulated means they are not enclosed. Encapsulated would be they are enclosed. So you have unencapsulated lymphatic tissue in areas like the digestive, respiratory, urinary, and reproductive tracts. The tonsils and appendix are composed of lymphatic nodules. And there's an area in the digestive region called Peyer's patches. And you can find this at the very end of the small intestine at an area called the ileum, which is going to be a bunch of these lymphatic nodules. Now, this is unencapsulated and it is abbreviated as MALT, the mucosa associated lymphatic tissue. It is definitely lymphatic tissue, and it's going to be in the mucosa of the body, kind of the fluids, the humors, if you will. But then we get into something that's more specific, anchored down, and that is the encapsulated, and that is the lymphatic organs. Lymphatic organs are the lymph nodes, the thymus, and the spleen. Let's take a look at what a lymph node is. A lymph node is oftentimes about an inch in size. Whenever you're feeling your neck, uh, usually when there is some kind of viral or bacterial infection or even a parasitic, you're going to have inflammation of this area because you're going to have a lot of lymphocyte activity going on, and these lymphocytes are most active in our lymph nodes. And so we're going to have swollen lymph nodes and oftentimes discomfort in that area when we have an infection. So what they do, they're going to be located with lymphatic vessels, and they're going to filter out pathogens. So they're going to collect pathogens and put them in a specialized location. Now that you have them trapped in a spot, you're going to use different kinds of cells that are going to eat these. And so macrophages are great at eating these. Macro means big, phage means eater. They are a big eater. And they're going to eat the foreign things. And those foreign things could be bacteria, it could be a virus, it could be other parasites, or it could be just debris, cellular debris. Anyway, those things are going to be consumed and broken down by those macrophages, and they're going to be found in groups or chains along a path of a large lymphatic vessel throughout our body. Now, major locations of lymph nodes. We have cervical, which means your neck. We have axillary, which means armpit. We have supratrochleal, which is going to be lower arm. We're going to have the inguinal, which is going to be, I'll show you in just a second. We have pelvic, abdominal, and thoracic. These are not found in the central nervous system. Here's a lymphatic vessel. Remember that they're about an inch long, and you can see the vessels that are leading to the lymph node that's there and the corresponding blood vessels that are close by. So looking at a cross-section of a lymph node, you notice that there's some new anatomy to identify. One is afferent is going to, efferent is going away from. So this would be an afferent lymphatic vessel. Notice the valves. So it's going to be moving towards the lymph node. Once in the lymph node, you're going to have the trabeculae, which are there, the germinal center for the B cells, lymphatic sinus. Around the outside, they're going to call that the capsule. Remember, these are encapsulated. Here's the hilum, and you have the overall net flow moving out of this towards the efferent lymphatic vessel. Here are those different regions. The cervical lymph nodes, you can see taking care of the neck region. Thoracic, it's in the thoracic cavity. Axillary lymph nodes in the armpit. Supratrochlear by the lower mid-arm. You have the abdominal lymph nodes, the pelvic lymph nodes near the pelvis, and the inguinal lymph nodes where the leg reaches the abdominal trunk. All right, so two primary functions of lymph nodes. It's to filter out potentially harmful particles in the lymph, like those viruses, bacteria, or even debris, parasitic cells. Also, immune surveillance. So, until now, we really haven't had much of a conversation about immunity. This is going to be monitoring the fluids of our body, and they're going to do this using macrophages and lymphocytes. There's two different categories of lymphocytes, B cells and T cells, B lymphocytes and T lymphocytes. Along with the red bone marrow, the lymph nodes are centers for lymphocyte production. The lymphocytes are going to attack pathogens in lymph nodes. This is their battleground, the lymph node. That's why it's swollen when we have an infection. Macrophages, they're going to engulf and digest these foreign substances, damaged cells, and even debris. All right, going from a lymph node to a different organ, a lymphatic organ, that's once again encapsulated, and that is the thymus. It's bilobed, and it's going to be in the middle mediastinum, and the mediastinum is specifically right on top of the heart is where this is located. And we have talked about this before, but the T lymphocytes are going to mature in the thymus. And so these progenitor cells, these immature T cells, are going to move to the thymus. They're going to mature in the thymus when it is time. So, thymosin, a hormone generated from the thymus, is going to stimulate T cell maturation. We don't need mature T cells unless we have a reason to have mature T cells. Your thymus is really, really large during infancy and even through adolescence, and it's going to start to decrease in size with age. So it shrinks at puberty, and it's going to be quite small in adults. And if you look at an elderly person, much of the actual thymus has been transitioned into adipose tissue, leading to a reduced immune system for the elderly. Here's the thymus right there, bilobed as indicated. You can see the thymus in a fetus is quite large, the thymus in an adult quite small by comparison. All right, the last lymphatic encapsulated organ to discuss is the largest, and that's the spleen. The location is going to be on the left side of your body. If you go down to the base of your rib cage and go up and under your rib cage, you're going to essentially be right about where you'd find the spleen. So it's in the upper left part of your abdominal cavity. It's going to look a lot like a lymph node, and it's going to be composed of two different categories of fluid, two different types. That's going to be called white pulp and red pulp. In white pulp, it's going to be loaded with lymphocytes. Now, the red pulp is kind of interesting. Red pulp is going to have red blood cells that are going to be there, along with the lymphocytes and the macrophages. But the main purpose of your spleen is to filter blood. So a it's a blood filterer, as of course, but the lymphatic material that it's picking up from that filtering of blood from that splenic artery, it's going to be sending that back lymphatic. Once again, this is one way. So the macrophages are going to engulf and destroy particles. The lymphocytes are going to defend the body against infection. In development, so when you're in the womb, your red bone marrow isn't developed enough to take the role of making your red blood cells. Instead, that is originally done in the spleen, specifically the red pulp. Its presence of red cells there, that's why. And the hemolytic erythroblastosis fetalis, where you have a mother who is Rh negative, gives birth to an Rh positive baby, and then she develops an immune response to the next baby that she would come in contact with that she's developing with Rh positive. She would then develop a response to. We talked about this when we talked about ROGAM and treating mothers with that. But let's say that we have erythroblastosis fetalis, where we have that fetus where it's killing all those red blood cells of our bone marrow. That backup mechanism to try to fix that would be to revert back to the spleen to make our red blood cells. Long story is that our spleen is our largest of our lymphatic vessels, and it's going to be the one having red and white pulp. Both have lymphocytes. Red pulp also has red blood cells. Here's a cross section of it. You can see the white pulp as the center regions there in this microscopic view. You can see it zoomed up on there, and the arterial and the venous sides. And the red pulp is going to be this region here where there's lots of red blood cells present. All right, guys, let's get on to 16.5.